Hey Geometries, this is Mr. Bloom. I'm going to be doing a video for the geometry review for page 830 and 834. These two pages are inside your notes packet, and these are the first things we're going to do. Now, as we go through, I'm looking at this evaluate each expression for x equal 5 and y equal -3. That does not mean that every time I see an x, it's always 5, and every time I see a y is -3 anywhere in the world. It means that only for these 16 problems where I see an x, I substitute the 5. Where I see a y, I substitute that -3. How will this happen? Well, as I'm going through here, I've got -2, and I've got 5 going in for x, and I square that. Okay, now that's going to be -2, and I'm doing my squared first because of order of operations. Exponents, parentheses, they're going to take precedence. Okay, please excuse my dear Aunt Sally. I go inside and worry about my parentheses first. There's nothing to do there. Then I go up to my exponent, which is a 2, and I square that, and so now it's 25. And this is going to be -50 for my answer. Now, as I go through these, I want to make sure you recognize that I want you to practice this. It's important that you practice it, and maybe you're going to do faster than I can, and that's fantastic. What I want you to do, though, is make sure that you're right. Just doing something and going through the process and not checking to make sure that you're correct in the process, that's an issue that we're going to have to correct if you're going to rush. So what I'd like you to do is do number 2 and then check your answer. Do number 3, check your answer. Do number 4, check your answer. And really do those problems and check my answer too, because if our answers are different, it's either one of us has got to talk to the other about correcting our work. Okay, so just keep us honest as we go through. So we're just going to run through each one of these 16. So I've got x equal 5 again, and y equals -3. So I'm going to take the opposite of what's inside that -3, okay, plus 5. Now I'm taking the opposite of -3, which is 3 plus 5, which is 8. And number 3, I'm going to take the opposite of the product of 5 and -3. Okay, now I'm putting in parentheses to show that I'm plugging that value in for my variable. So I've got -5 and times -3, which is +15. So this is +15 is my answer. That's +8, and this is -50. Now as we go on, I hope you're starting to notice they're getting a little bit more involved, and they're getting tougher to do. So again, still x is 5, plus 5, y is -3, and I'm going to divide by 5. Now, I got to do this stuff inside this parenthesis first, and so I want to make sure you recognize I'm doing this stuff. And of that stuff, I've got to do this multiplication before I do anything else, because multiply and divide have to happen first. So with that, inside the parenthesis, I am looking at this idea that I have 5, not going to change that at all, plus, we're going to call that a -15, okay, and that's the stuff inside there, and I'm still going to be dividing by 5 after I finish that. Now, I'm going to kind of lap over my problem 8 just to make sure things are clear. And I've got -15 and 5. I add those, and it's going to come out as -10 divided by 5, which will give me a -2 for my final answer for this problem. And we're going to group this together. So now you guys can just go ahead and bring that up. And apparently I didn't group those well, so we're just going to bring those over, and you can't tell that that's what we did. But make sure if there's any questions, you ask. This next one, again, keep going. Again, you are doing them yourself and checking your answer. Do them yourself, check your answers as you go. Keep me honest. Keep yourself honest as well. Now, this looks an awful like the previous problem. And I'll have students go, well, you know, it's like, it's got to be -2, Bloom, because they're the same numbers. We're grouping them differently this time. Instead of using parentheses, we are actually using the order of operations, PEMDAS, you know, parentheses first, then it's exponents, then it's multiply and divide left to right. So I'm going to multiply here first, so I got 5 plus -15 divided by 5, and then I got 5 plus -15 divided by 5. So now I do this next. So I've got 5 plus -3. So this actually comes out to be +2, not -2, okay? Because of the way the precedence of order of operations requires us to do this problem. So again, pay attention to order. Order matters, and don't rush things, because sometimes when you rush it, you just do it real quick and you forgot which order, or you didn't use the order of operations. So in 6, we got y is -3. So inside my parentheses, I got this as -3, and that's squared up top. So I got to do my parentheses, it's +6. Okay, squared, that ends up being a +36 is my final answer. Keep going, do 7, 8, 9, and then turn me back on just to check your work. Okay, we're back. So now I'm looking at this. I got 2 times -3, okay, squared. And this looks a little different because this negative isn't there. Okay, so now inside I got -6, but I'm squaring a negative, so it's still +36. So we're doing great here. And now x is 5 still in this problem, and I got take the opposite of a -3, and I'm going to square this solution. So now I've got 8 inside here, because that's 5 plus 3 squared, which is 8 squared, which is equal to 64. In 9, I got x is 5 again. 5 plus 1 all over, again, y is -3. Well, this becomes 6 over -3. Now, remember, a fraction bar, and that's what this is. I like talking about these as horizontals. Don't write them as slants. Always do them as horizontal fraction bars. Write your fractions as horizontal, not the slanted ones, because it makes more sense this way. It also makes more sense in your calculator. I've got 5 plus, I'll do the 5 plus 1 first, and anything on the bottom second, you know, and then I'll combine them, and this becomes -2. Okay, so make sure that order is careful, and make sure you're being careful to be aware of that order of operations as we look through these problems. Okay, go ahead and do 10, 11, 12, 13, 14, 15, and 16, and then turn me back on and just for checking your work. Now, when you're checking your work, if you notice my answer and your answer aren't jamming, see if it was, gosh, was it Bloom that made a mistake, or was it me that made a mistake? And just go through the order of operations and see what's going on. Okay, welcome back. We got y is, again, still -3. I'm plugging that in. X is 5. Again, y is -3. And now I've got -3 minus, now remember, I've got to do stuff inside here, that's 8. So this becomes -11 when I'm done here on that one. Okay, we're going to group these in. I just want to make sure you all see what I'm writing. I don't want to chunk it together. Gosh, what did I do with that? Let's do that again. Group. Oh, that's why. So we got to group this up. So it's all grouped up, that's -11. Here, this is kind of an interesting one. I got the opposite of -3, because that's what y is, and raised to the 5th power. Well, we're going to pull up the calculator for this, but right now I'm going to know it's going to be a positive answer, because this is an odd power, and a negative, an odd number of times is still a negative. But then on the opposite, I take the opposite of that value because of the one outside, so I know this answer will be positive. So I'm going to take 3 times itself 5 times. And that's going to be 243, but we're going to double check this with the calculator, and because it gives us an opportunity to work with our functions on our calculator. Now, if you have a graphing calculator or if you have a regular calculator, you have a negative sign down here in the bottom corner right next to your equal signs if you have a TI Texas Instrument calculator. That positioning is the same in both those calculators. Now, what I want you to realize is that this negative is different than the subtract sign. So be careful. If it doesn't come up right, you might want to retype it in, paying attention to which horizontal segment that you put in before your problem. But we're going to put it in exactly as we see it here on the board, and that's a -3. And I'm going to raise that to the 5th power. Now, there's a couple ways I can raise that to the 5th power. I can use this caret key, this up key, and that allows me to go up, and it gives me an exponent, okay? And I was supposed to hit 5, so we're going to go back here, and we're going to hit 5. And then I hit that enter, and you know I forgot one other thing. And I can enter this. I can go second, insert my negative, because I wanted to make sure I have a negative. And now I can hit enter, and it's my answer is 243, as I thought it would be. Now, there are some calculators out there that will have a different look. And that different look, instead of having this up here by itself, you'll have this in here, and then you'll have this, and that number will be on the same line. That'll be okay. It'll still be the same thing, 243, but you just have to become more aware of what your calculator is going to say or look. Or I guess you got to talk calculator, okay? So you make sure you're comfortable with the notation that it's going to use when you're using it. Okay, now in 12 here, let's move these up. I have a combination of things, and look at this fraction bar. I have 2, 1 minus, now x again is 5, okay? And I have y, which is -3, minus 5, which is x. Now, I do everything on top, so I'm going to do the top stuff. My top stuff is 1 minus 5, which is -4. So I got 2 times -4. I know that's going to be -8 up top. Okay. Now, my bottom stuff, I've got -3 minus 5. Now, that's -8 in itself. So if I got -8 over -8, I get 1 for my final answer. Okay. And we got our last 4 here. Now, x again, still for these problems, we said x is 5, and that's why I'm plugging 5 in for x. Other problems will have different values defined for your variables. So pay attention to directions. It's going to mean a lot for you to get those done. Now, when I'm doing this, I'm going to multiply -3, and I'm going to subtract 5 from that. So I got 5 times -3, which is -15, minus 5, which is giving me a -20 when I'm done with my problem. Now, I'm going to flip this around, and I've got x is 5 still. I'm going to make these smaller so they don't munch together, so we have those separate. So we're going to group that together. And I'm looking at x is 5 minus a -3 times 5. Okay, so I got 5. Now this is minus a -15. So now this is 5 plus 15, which is 20. So one is -20, the other one's +20, and it was a difference of me flipping a couple things around. So it's important for us to pay attention to order and attention to where those orders are in the problems, and we'll get this all scrunched together. Now these last two get a little bit more high-techy. It's more stuff we put in, the harder it becomes. So we just got to keep focus on what we're doing. Since we have a fraction bar, we're going to do everything on top, we'll do everything on the bottom, and then we'll put them together. The y is -3, and this is raised to the 3rd power, minus x, which is 5, and the x is 5 minus the opposite of 3. Okay, so I've got +8 on the bottom here. Okay, as I go down, and I'll go down this way. This is for space sake. I got 8 on the bottom. On the top, I've got this is -27. -27 minus 5. Well, that gives me a -32 up top. and an 8 on the bottom, and it's a positive 8. So my final answer when I take my negative 32, dividing it by 8, is negative 4. And our last one here, let's change colors. I have the opposite of my negative 3 times my 5 minus 3 squared. Remember, 5 is x and negative 3 was a y. But this is important to do because I have to combine these here. So now, with that in mind, I've got the opposite of negative 3, which is, I can do that, that's 3. But I have to be careful here. This is 2 squared. So it's not 3 times 2, it's 2 squared, which is 4, because order of operations requires me to do parentheses and then exponents. So that's why I'm doing the exponents, and this becomes 12. Okay, I hope that's helping out. Now we're going to get to that next page, and we are talking about simplification. The difference between simplification and evaluation. Evaluation actually gives you values for your variables. Simplification doesn't give you numbers in for your variables. You're going to combine like terms. Okay, so you're looking for things that are alike. I've got x's and I got plain numbers. Okay, and maybe I'll give you a different color for those plain numbers so you can see that that's what I'm doing. So I'm just going to combine the terms the way I'm asked. So I got 6 minus 4, which is 2, and I got 2x. Let's do this a little differently. I got those underlined as red. 6 minus 4 is 2, so now I've got 2x. And then I've got plus 8 minus 5, which is just 3. I am done with this problem. I have simplified it down as far as I can go until I either know what it's equal to or know if I can evaluate it for x being a value. Now in 18, that looks a little tough. This is not a 1, this is an L. And that's length plus width. I want to kind of harken you back that if I have a perimeter, okay, or a rectangle, and I want its perimeter, I have width and length. Well, if I'm going to travel from this corner around my rectangle, I am going to go my length plus my width plus my length plus my width. Well, that's just adding L and W together and multiplying by 2. That is my equation for perimeter. And that's all I'm doing here. In this particular case, for us to simplify, we're going to get rid of the parentheses. So I'm just going to distribute the 2 across. And it's a 2, it's not a 3, Mr. Blum. So we're going to look at that and we're going to get that done. Now, to go with this idea of distributive property or getting rid of the parentheses, in 19 and 20, you're doing that very same thing. You're distributing. Give 19 and 20 a try. Turn me off and go do them yourself. After you are done with those two, turn them back on and check your solution. Welcome back. So I'm just going to distribute the negative, and it's like distributing a negative 1 to each one. So this is negative 4x minus 7, and we're done with that. In 20, I'm doing the same thing. I'm distributing this y. So I got 4y minus y squared. And that's y times y. When I have two numbers that are exactly the same, I have them squared. Okay, now, and as we go, you're starting to see them. They're getting a little bit more technical. They're getting more stuff added in, but we're still doing the same properties. Okay, in this case, I'm still distributing. And notice, please, that there is no plus or minus sign there. It's a multiply. This implying it's multiply. 4x is the term that is multiplying across, and this happens to be a negative 4x. So I want to make sure you notice that that's different than this one. This one's telling me in 22, I've got 3x minus the quantity 5 plus 2x. There's a different way that we treat these because how they are written. In 21, it's a distributive property. So I've got negative 4x squared plus, because it's negative 4 times negative 2, 8x. Now, this is as much as I can simplify it down until I know what the value of x is. Now, in 22, the difference is I would distribute my negative. So now I have 3x minus 5. And because this is a plus, it's minus 2x. I want to make sure you see the difference in these two problems, because now I can combine my like terms, which is 3x and 2x, and it's 3 minus 2x, which is x minus 5, as my final solution. Now remember, when I start combining like terms, I'm looking for the letter, okay, the power, and the number outside is just added together if the letter and the power are the same. Now in 23, with that idea in mind, I have my letter and power of my t squareds are the same. I know for t that letter is the same, but it has to have the same power. So I have 2t squared minus 5t squared gives me a negative 3t squared. And I don't have another t value or term in this relationship. So what I'm looking for is just plus 4t. Now in 24, I've got a binomial squared. Okay, binomial is a two-term value. I got r minus 1. Now, I'm not sure if you remember FOIL. Okay, FOIL, this r minus 1 squared, is the same as this. And remember, FOIL was first, let me get this moved over a little bit. It's a little out of my area there. So FOIL is first, outside, inside, and last. Okay, so let's talk about our firsts. Our firsts are r and r squared. So r times r, so that becomes r squared. Our outsides here is r times negative 1, which is negative r. Our insides are negative 1 times r, which is still negative r. And our lasts here become negative 1 times negative 1, which is plus 1. Now, FOIL, when I do this, the inside and outside terms will combine if it's just a binomial times a binomial. So I have r squared minus 2r plus 1 as my simplified solution. What I'd like you to do is do 25 on your own. It's similar, it's not the same, and see what happens. Now, welcome back. Now, keep in mind, FOIL is a shortcut and a mnemonic memory device to keep in mind. I do first, outside, inside, last on binomials. And you got to be careful, because the way it's written here, this looks like, oh, I'm going to square 1 and I'm going to square r. But when you think about that, you forgot the inside and outside terms. So you have to make sure you're aware that you're doing this value or this problem when you do FOIL. Now, I know I wrote out 24. And I was very careful. FOIL is supposed to be a shortcut. My firsts are 1 times 1, which is just 1. My outsides are 1 times negative r, which is negative r. My insides is negative r times 1, which is that. And my last is negative r times negative r, which is just plus r squared. And now it's 1 minus 2r plus r squared. Now, what's interesting about this is although we flipped them around, when we squared them, it's the same value. I just have a jumbled order. Okay, now, taking your FOIL skills, go after problem 26. And I'm going to group these real quick because of space use. Okay, and that's my answer. In 26, I got my first, y squared, My outsides, now I'm going to start talking FOIL in the air. My outsides is -3, my insides +1. So -3 plus 1 is -2y. My last is 1 times -3, which is just -3. And that's the benefit of being able to do FOIL. I was able to multiply those two binomials using that mnemonic device of FOIL to remind me how to do my multiplication, but I didn't show my work. Now, if you're kind of a little lost on like, Bloom, where did you get all that stuff? I'm more than happy to show you what I did and how I came about it. So I had my first. My first was y squared, okay? My outsides, okay, my outsides here was -3y. My insides was just y. My last was -3. And then I was able to combine these to be that value, and these two values just dropped in place because they did not combine with anything else. And that's how I did it. But remember, FOIL is a shortcut to allow me to do it quicker. Now, 27, I'm just going to combine like terms what I've got. So I've got 4h plus 3h is 7h. I got -4 plus 3 is -1. That's the best I can do. 28, be careful, notice the negative. It's not a multiplication. I'm not distributing the pi r, I'm distributing the negative sign. So now I've got pi r minus 1 minus pi r. Remember, that's distributed there and there. Well, these two knock each other out because they become 0, and this is just equal to -1. And that's my answer. 29, 30, 31, 32 are all multiplication FOIL type things. Give them a try. Really think about your FOIL order and then turn me back on, because if you're not getting it, you've got to seek out a solution with your instructor or somebody who really knows what's going on that's sitting next to you and see what's happening. Give them a try and then check your answers. Okay, welcome back. We're doing FOIL again. So my first is 2x squared. My outside is -x. My inside is plus 8x. My last is -4. Remember, normally I just do those in my head, but I want to make sure you know that I'm going to go 2x squared. These combine to be plus 7x minus 4. Again, I'm going to make this smaller. Sorry, guys. All right, let's get that. Oh, there it goes. Okay, this next one's interesting. It requires me, according to order of operation, to square 1 minus r and then multiply that part of the multiplication with 2 pi h. So it's really two parts here I'm going to be working on. So I'm going to hold out that 2 pi h, and I am going to multiply my 1 minus r times 1 minus r, because that's what it says for me to do. And that means the same thing. And so now I got 2 pi h. And remember, I FOILed this earlier. That's actually up here. Okay? And my first, okay, 1, my outside and inside, minus 2r. My last is going to be plus r squared. Now I'm going to multiply that with this. So now I've got 2 pi h minus 4 pi rh plus 2 pi r squared h. Okay. Now, if you flip-flopped these letters, you're okay, because order of operations with multiplication, when I have just a group of numbers multiplying together, will allow me to have the same answer no matter if I do h times r or r times h. So if you flip those, you're fine. Okay, so that'd be our solution for this one in problem 30 right here. Okay, now on 31, pay attention to how it's written. Pay attention to how it's written. You'd think it's almost a trick, because if you just go really fast, you don't notice those negatives, but that negative is supposed to be distributed here. Okay, so I've got 3y squared minus y squared minus 3y. Now keep in mind that the order of operations in order for me to combine things together, I shouldn't say order of operations, to simplify, in order for me to combine things together, I have to have the same base, letter, and power. So these two can be combined together. This one can't, this negative 3y cannot because it doesn't have the same power. So now I can look at it as 3 minus 1, because there's a 1 out front here, that's a 1. And so that's 2y squared minus 3y. My last one, I have a FOIL, two binomials multiplied together, but I'm taking their opposite. So I have the opposite of x plus 4 times x plus 4. So now I'm just going to hold that out. I've got x squared, and I'm going to FOIL 4x and 4x plus 8x plus 4 times 4 is 16. Keep in mind, I got to take the opposite of everything. So now opposite of x squared, opposite of 8x, opposite of 16 is my final answer. Now I've got two word problems. I know it's your favorite thing to think about. You want to read and do math all at the same time. Well, it's kind of a combo, but no, I lied. I'm one page off. I hate it when I lie. I guess I'm a rug because I just lied. But don't wipe any like shoes on me. Hey, what do you call a guy laying in front of laying in front of a door? What would his name be? I know it's kind of random, but his name would be Matt. Okay, let's move on. All right, so now we looked at evaluation, we looked at simplification. Now we get to look at solving. Solving will let us use evaluation or simplification, and then after we finish solve, we can evaluate to check our work. So now I'm looking at problem 1. I got 3n plus 2 equals 17. And remember, the purpose of this is I want to get that 3n by itself. So I do the opposite of how the 2 is connected together. So now I've got 3n equal to 15 because I'm going to subtract 2 from both sides. I now divide by 3, so n is equal to 5. Now, please notice how I showed you my work. I did not tell you, I told you I was subtract 2. I did not show that I'm subtracting 2. I told you I was divided by 3. I did not show it. And I'm getting you ready for what we're going to do in chapter 2 with working with proofs and doing algebraic proofs. I think that's when we start doing those. So make sure that you're careful. If you're showing now, that's okay. Whatever I do the one side of the equation, I'm still doing the other. I just happen to be a little neater with my work. And problem 2, I'm going to add 2 to both sides. Okay, 5a is equal to 2 plus negative 12, so it's negative 10. I'm going to divide by 5 and find that a is equal to negative 2. Now, in 3, doing the same thing, I am looking at each step, and after I do one step, I'm going to show you the result. So I'm going to subtract 4, and I have 2x, so 10 minus 4 is 6, and I divide by 2, and it's x equal 3. Now, in each one of these, I could plug back in this value, and I can evaluate. 3 times 5 is 15, plus 2 is 17, and check my work. And I can plug this back in, and negative 2 times 5 is negative 10, minus 2 is going to give me a negative 12. So I'm checking it to make sure it's right. And I got 3 times 2, which is 6, plus 4 is actually 10. So those are working out. Now, in this next one, I want to show you something because I've got choices sometimes, and sometimes when I do some things, students go, "Oh, well, that's never something I've ever learned." But other times you go, "Oh, well, I can do it that way, so that's kind of cool." But I want to talk about it real quick. Generally, when people come across this problem, they'll go 3n minus 12 equal 15 because they distributed everything going across, and then they start solving. They're going to add 12 to both sides. So I have 3n equal 27, and they're going to divide by 3, so n is equal to 9. Now, that's perfectly fine. It's an answer that totally works. I take that 9, I plug it into n, and 9 minus 4 is 5. 5 times 3 is 15. Another way of looking at this problem, what if I divided by 3 first? If I divide by 3 first, now I know n minus 4 is equal to 5, because if I divide this by 3 and this by 3, I dump the 3, that's where my n minus 4 came from, and 15 divided by 3 is 5. At this point, I can add 4 to both sides, and n is 9. It's the same answer, a little less work, and I've justified where I've done my work, okay? So you have a choice when you do that. It's up to you. Both are correct. In 5, 6, 7, and 8, go for it. Go ahead, work those, make sure you're getting comfortable with them, and then we'll do it. I'll come on and after you turn me back on, and we'll correct it. In 5, I've got to get the y's together. Okay, so when I get the y's together, I'm going to subtract 2y from both sides. So 4 is equal to 6y, because 8 minus 2 is 6. Now, I've got to be careful here. I want to solve for y. I want to know what the value of y is. So because of that, I want to do the opposite of how they're linked. This is 6 times y, and I want to divide by 6. When I do that, I got 4/6 equal y. I just created an F word. I know, fraction. It's just kind of a scary thing, but because it's a fraction, I have to reduce it. 4 and 6 both have a factor of 2, so this is 2/3. So y is 2/3. Now, you probably on your calculator went, well, Bloom, I put it in my calculator, and this is what happens. Let me get these colors off my calculator for a second. And you were like, well, gee, 4 divided by 6, that's 0.6667. So a lot of people will say, well, that's 0.7. Well, that's true if I asked you to round it to the nearest tenth. But since it's a non-terminating, always repeating decimal, because it's always 0.6 and your calculator rounded up right there, it's more correct to leave it as a fraction 2/3. And we want you to become friendlier with fractions. So I want you to be thinking fractions are friends, not foe. Okay, fractions are friends, not foes. So let's go on to 6 and let's get this thing going. I've got my z's I got to get together. These are actually more than the 2 steps. I got to get my variables together before I solve. So I'm going to get the -6 over to the right. And the only reason why I'm doing that first is that I'd be working with a positive value on my term with the z. Okay, so I've got 1 is equal to 13 plus 3z. I subtract 13, I get -12 is equal to 3z. I'm going to divide by 3, and I get -4 is equal to z. And I'm comfortable working with that way. And whether you did it the other way or this way, -4 is our value for z all the time. Now again, in 7, that's a negative, or a subtract, so I'm subtracting here. So I'm going to distribute that and combine like terms before I do other things. So I've got 6 minus 3t minus 4 is equal to t. I'm going to combine like terms, so I've got 2 minus 3t is equal to t, and 2 is equal to 4t. And just like everything else we've always done, I have a situation where I'm solving for t. So I'm going to divide by 4, and I'm going to get, if I bring this up, I'm going to divide by 4. I got 2 divided by 4 is equal to t, and that's 1/2 is equal to t. So that's really my solution. 1/2 is equal to t. And I'm just going to double check. So I have 6 minus 3t minus 4t. I've got -4, 2 minus 3t. That's me 4t. Yep, I'm happy with that. Okay. So I'm just going to condense that down. Nope, I don't need to. We got plenty of room. So now in 7, in 8, I'm looking at this idea. I'm going to distribute the 2. Now, this is much like this one up here, number 4, but because the 2 doesn't go in the 7 evenly, I'm just going to decide to distribute the 2. Okay, but since it's 2 and it'd be terminating decimal on the 7, I could go 3.5 and I could work with it that way. But I'm just going to distribute the 2 because it doesn't go in the 7 nice and neat. And this is going to be plus 9. So I've got negative 2 times 4 is negative 8. Negative 2 times negative 4.5 is 9. I'm going to subtract and I get negative 2 is negative equal to negative 8n. Again, I'm going to divide the value that's with my variable. That's why I'm going to come up with negative 2 divided by negative 8n, which really is just 1/4 when I reduce. Okay, and it's just equal to 1/4. That's my final answer. Now, I'm hoping you start to notice that the further along we're going, the more technical these are getting, and the more care I have to pay attention with my signs, my order of operations to undo everything. In 9, this looks really tough, but you see that subtract? The subtract follows everything, so this is really just w plus 5. The parentheses just drop away. Minus 5 is equal to 2w plus 5. Because now there's nothing outside these parentheses for me to do anything with, I look at that and that's going to be 0. So w is equal to 2w plus 5. I subtract 2w from both sides and I get negative w is equal to 5. So I divide and I know that w must therefore be negative 5. Okay, we got 3 left here on these, and I want you to be careful about stuff. Now I'm going into fraction land. I know, Bloom said the F word again. Fractions. I want you to know that we're going to treat this differently, but before we even get to that, this is just going to be blob. So I got blob minus 10 equal 30. Well, any time I've ever done this, I do the opposite of minus 10. So I'm going to add 10. So 5/7 p is equal to 40. Now, I'm not sure if you guys remember reciprocals, because when I divide by a fraction, that is the same as multiplying by that fraction's reciprocal. And reciprocal is just putting a fraction on its head. Okay, so this is the fraction's head, the 5. So if I multiply this by 7/5, that becomes 1. If I multiply this side by 7/5, p becomes 56, because that becomes 8, and 8 times 7 is 56. Now that's a fast way of doing this problem. There's another way of doing this problem. If I could do it this way. Again, it's 5p over 7 equals 40. Notice how I rewrote my fraction. Anytime I have a whole number times a fraction like this, the way it is, that letter actually goes to the numerator of the fraction, not the denominator. Now I'm going to multiply by 7 to clear out my fraction. So I've got multiply by 7. So I got 5p is equal to 280. Okay, that's 4 times 7 is 28 and a 0. And I divide by 5, and guess what? It's going to be 56. So both ways will work. I like multiplying by the reciprocal. It's faster. But, as you ease yourself into these, just practice both. Be comfortable. Now, in 11, I have a fraction with my variable. And multiply by the denominator of the fraction, I will clear the fraction. And so what that means is this. I am going to take, and I'm just going to get rid of this stuff here a little bit so I have some room. I'm going to take and multiply both sides by -3. Okay? And I'm multiplying both sides by -3. What that's going to do, I'm going to have m plus 9 equals -3. Now I'm multiplying everything by -3. I'm going to add 9, and I got m is equal to -12. Now I've got some folks out there going, Bloom, seriously? -12? Let's just check this one. We're going to evaluate this. So according to the original, if I go -12 divided by -3, remember I just plugged that in, -3 is equal to 1. Well, that's 4. -3 is equal to 1. Hey, that totally checks out. Boy, that really does work. That's cool. Now in 12, go for it. See what happens. Do the distribution, do the combining like terms, see what's going on. So you got 5k plus 2k plus 2, because I distributed here, equal 23. This is 7k plus 2 is equal to 23. I'm going to subtract 2. 7k is equal to 21, and I find out that k is 3. Now, we got 2 problems left, my word problems. I know I alluded to them earlier, but I want you to think about this. Twice a number subtracted from 35 is 9. Twice a number subtracted from 35 is 9. If I have twice as much money as you have and you have $10, how much do I have? Everybody's screaming 20. By the way, you're talking to a video, it can't hear you. So twice a number subtracted from 35, twice a number, and that number is unknown, so twice a number, and they say, ooh, subtracted from 35, twice a number subtracted from 35, twice a number subtracted from 35 is 9. So I'm going to subtract 35 from both sides. So I got negative 2x is equal to, if I go 9 minus 35, remember, some people, just, when they're doing this, they don't believe me when I come up with 26. So I've got, and it's negative 26 minus 35, and it's going to be negative 26. At least it should be. And somebody should just go 9 minus 35, not 9 minus 32. 9 minus 35. Okay, should be 26. Negative 26 is what we get. So we're over here. We got negative 26. And now I divide by negative 2, and x is 13. Now, did you notice that I read that like 3 times and I reordered stuff after I wrote stuff down? And they say, what is the number? So let's just double check. So I got 35 minus 2 times 13, and that's 9. So that checked out because that's going to be 26. 35 minus 26 is equal to 9. Sorry, I kind of did a little faster in my head. Okay, so in 14, this one looks really tough, but it's not so bad. The Johnsons pay $9.95 a month plus 3.5 cents per minute for local phone service. And people are like, where did he get 3.5 cents? This is 3 cents and this is half a cent. So 3.5 cents per minute for local phone service. Last month they paid $12.75. That was their big bill. I wish I could do $12.75. How many minutes of local calls did they make? So the total is $12.75. Okay, and now I'm looking at this and I've got, well, I got 3.5 cents per minute, but I'm doing it in terms of dollars. So I've got my 3.5 cents per minute, and I'll call that M, plus my monthly pay, no matter what, is $9.95. Okay, so that's my setup. And it's the setup you got to reread and think about. This is my total cost. This is my monthly cost plus my cost per minute. Now I subtract my $9.95, and I've got to get my calculator back out here. So I'm going to go over here. I got $12.75, 12.75. Somebody has to actually have a 12 there. 12.75 minus my $9.95. And I'm just going to double check to make sure those are my numbers. $9.95 a month. I hit enter. And that's $2.80. So I've got $2.80. $2.80 is equal to 0.035 minutes. So I'm going to find out how many minutes of local calls we made. So 2.8 divided by 0.035. So I'm going to go divided by 0.035. Remember, that's 3.5 cents. So that's 80 minutes of calls. So 80 is my answer. So 80 minutes of calls. Okay, that's what we've got. We're all good. I hope things went well. Have a great day.